Hi kids. This time we have our buddy Joe, who is 70 kilograms. He's standing in an elevator, which is an 800 kilogram elevator, and he's standing on a bathroom scale. You might ask, well, why is he standing on a bathroom scale? Why not? He might be doing an extra credit project or something like that, but he's in an elevator on a bathroom scale. It says we're going to do a two-parter here. That the first part is the scale reads 500 newtons, and we want to figure out what is Joe's acceleration if the scale is going to read 500 newtons. And then part B is going to be what is the tension in the cable for the elevator. So we're going to do part A first. Again, as always, our first step is we want to draw a picture. So here is my picture of Joe. There you go. He's a little bit of a square. And if we want to draw forces acting on Joe. So the downward force acting on Joe is our force of gravity, as always, so it's going to be Fg. And our upward force acting on Joe is going to be the normal force, and the normal force in this case is going to be coming from the scale. So that is going to be an upward force of Fn. And Fn. Okay? And at this point, you may not know which one is bigger and which one is smaller. So if you're not sure which size is which, don't worry about it. We'll have to make a guess a little bit later and see if we're right. But step one, here's Joe, and we have our forces. Step two is we want to use our free body diagram, and we're going to use this to write an Fnet equation. So we're going to say Fnet, and this is Fnet for Joe, equals... And in this case, I'm going to guess, we have to guess which one is which. I'm going to guess that my Fg is bigger than Fn. So we'll say Fg minus Fn. And we also know that Fnet equals Ma. So I could say Fg minus Fn equals Ma, because Fnet equals Ma. Now, so I did step one, step two. Now I want to write, plug in numbers that I know. Now we know that Fg is equal to m times g. So Fg for Joe is going to be 70 times 9.8. So I'm going to have 70 times 9.8. Given in this problem is that the scale reads, which is the normal force, is 500 newtons. So I can plug that in. 500 newtons equals... This is going to be Joe's mass, which is going to be 70, and then times the acceleration. Now, if we use our calculator and take 70 times 9.8, we get 686 newtons. Minus 500 is going to be 186 newtons equals 70 times A. And you solve that for A, and you get 2.66 meters per second squared. And that is positive, by the way, so that means that we did guess correct when we thought that Fg was bigger than Fn. If we guessed wrong, which is fine, we would have ended up with a negative acceleration, which means he's not accelerating the way we thought, but he is actually accelerating down. So the acceleration is going to be pointing down. And you might ask, well, what does that actually mean? Now, if you think about riding an elevator, when are you accelerating down? Well, you're accelerating down if, let's say, Joe's on the 10th floor and he presses 1. At the beginning, he's going to have to speed up going down. That would be one case. Or if Joe is going up and slowing down, his acceleration would also be pointing down. So it is his acceleration is 2.66 meters per second squared down. Okay, bye kids. Hi kids. Now we're going to do the second part of this problem, which is what is the tension in the cable. So again, I got to do my first step. The first step is to draw your free body diagram. So here is, and this looks just like the elevator. There's a box to represent the elevator. And we want to draw the forces acting on the elevator. Now remember, our elevator has Joe in it, so we'll have to keep that in mind a little bit later. But the forces acting on our elevator, just like before, we have the force of gravity down. And just like before, we're going to have, actually not just like before, because before it was the normal force up. In this case, the force up is actually the tension in the cable. So I'm going to have F of T acting up. So now if I did my first step, so now I got to do my second step, write my F net equation using my picture. And I'm going to again, or actually I already know that my acceleration was 2.66 meters per second squared down. So that means that I know that it is going to be accelerating down. So I'm going to say Fg minus Ft. And then we know that that has to equal m times a. So Fg minus Ft equals m times a. And now this time, my Fg is going to be, let me erase this. My Fg is going to be 870 times 9.8. So 870 kilograms times 9.8, because Joe is in the elevator, minus my Ft equals 870 times 2.66. So if we do the math, we're going to end up with times 870, and then minus 870 times 9.8. And my tension in the string, in the cable, would be 6,214.3 newtons. And of course, just like my picture shows, that would be pointing up. So attention in the cable, 6,214.3 newtons. Bye, kids.